Ask my instructor 3.8.13. In this problem, we have a swimming pool that's 50 meters long and 20 meters wide. Its depth decreases linearly along the length from 3 meters to 1 meter. It is initially empty and is filled at a rate of 1 cubic meter per minute. How fast is the water level rising 160 minutes after the filling begins? How long will it take to fill the pool? This problem is difficult in terms of the geometry. If we put the pool, turn it so that we're looking at the side of the pool, then this is what it would look like. We've got the water level at say 3 meters, and then at the 2 meter mark, that's the shallow end, and then down at 0, that's the deep end. So we have two figures. We've got a rectangle and a triangle that we're dealing with. And so the first question I would want to know is, what part of this geometry are we looking at when we talk about 160 minutes? Are we up in the rectangular region or down in the triangular region? So the question is, what is the volume of water in the pool at 160 minutes? If I know how much water is in the pool at 160 minutes, then I can know whether I'm in the triangle or the rectangle. And the geometry is going to be different depending on where I am. Well, at 160 minutes, the volume of water in the pool is 160 cubic meters. So where are we at 160 cubic meters? Well, let's just look at the geometry of it. The rectangular region gives us 50 times 1 times 20, or 1,000 cubic meters. The triangular region also gives us 1,000 cubic meters. So at 160 cubic meters, we're really still in the gray area, and so the geometry of what we're looking at is the geometry of a triangle. So let's look at the geometry of a triangle. If we're down in the rectangular region, then the volume is given by 1/2 height times base times 20, because 20 is the width of the pool. Well, you can see that this is a volume formula has two variables, height and base. Is there a way that we can eliminate one of these variables? Well, sure. We've got a similar triangle. The ratio of height to base is equal to the ratio of 2 to 50. So which variable would we like to eliminate in order to do the problem? So let's go back to the problem. We're asked in the problem, how fast is the water level rising? That means that we're looking to find dH dt at 160 minutes. If we're looking for dH dt, then we want our volume formula to be in terms of H. So we find out what B is in terms of H. B is equal to 25H. And then we replace B with 25H. And that gives us a volume formula just in terms of H. The first thing I'd like you to notice is that we can now find what H is, what the height of the water level is at 160 minutes. All we have to do is, instead of V, put in 160 and then solve for H. If we solve for H, we get 4/5 of a meter. So at 160 minutes, we have 160 cubic meters of water in the pool, and the height of the water level is 4/5 of a meter. So it's not very deep. Now let's get to answering the question. To do that, we have to figure out how dV dt and dH dt are related. So take the derivative of our volume formula, volume equals 250h squared. Take the derivative of both sides with respect to t. And when we do that, we get dV dt equals 500h dH dt. And then solve for dH dt. dH dt is the ratio of dV dt and 500h. Let's go ahead and evaluate this. We know that dV dt is 1 cubic meter per minute, and we also know that h is equal to 4/5 of a meter. Let me just remind you that we're evaluating dH dt at 160 minutes, and at 160 minutes, h is equal to 4/5. dV dt, that's constant, so that would be regardless of what time it is. All right, so anyway, plug those values in, and then find out what you get for dH dt. I get 1/400 meters per minute. So that would be barely detectable, probably not detectable by the human eye unless you have a lot of patience. All right, so just let's summarize here. At t equals 160 minutes, we found that the volume is 160 cubic meters. And then we found that the height is equal to 4/5 of a meter. And then we found that dH dt, the rate at which the water level is rising, is equal to 1/400 meters per minute. All right, so are we done with the problem? No, we got one more question to answer. How long will it take to fill the pool? This is actually not a calculus question. To figure out how long it takes to fill the pool, we just ask, well, how much water is there? And the pool will hold a total of 2,000 cubic meters. And then it's filled at a rate of 1 cubic meter per minute. So we're talking about 2,000 minutes. And my math lab doesn't ask you to do this, but I like to calculate what that means. 2,000 minutes is about 1.4 days. All right, let me know if you have any questions on this.